Hi, this is the Masking Handbook for Audiometry. In this video, we'll be looking at this paper, Masking in Clinical Audiometry. This paper from 1959, produced by Liden and his group from Stockholm, was notable as they developed a device that could produce narrowband noise signals for masking. They also articulated the approach for masking, which would come to be known as the Plateau method. In this paper, their term for this method was called the control test. The control test involved increasing the masking noise in steps, retesting threshold during the increases, and observing if the threshold changed. When the hearing threshold did not change during the increases, it was proof that the measurement came from the test ear. They produced a graph that illustrated their control method. The chart showed the three possible masking situations. Undermasking, when we're not delivering enough noise to the non-test ear to mask the signal. Appropriate masking, where the masking level is effective and appropriate. And overmasking, where the masking noise to the non-test ear could cross and contaminate the testing in the test ear. The method eventually came to be known as the Plateau method because of the shape of the graph. They reviewed a hypothetical case to illustrate the technique. It was an asymmetrical hearing loss, with the left ear being worse than the right. Although we wouldn't know this prior to testing, the presumption is that the left test ear has a sensory neural hearing loss. The right non-test ear has a bit of conductive hearing loss. We'll start with 25 dB of narrowband masking noise at 1000 Hz to the right ear and try testing bone conduction in the left. The unmasked bone conduction threshold, which was initially at 5 dB, now changes to 25 dB. Since the bone conduction shifted with the introduction of noise to the non-test ear, we know that that initial unmasked bone conduction threshold was not coming from the left ear. If it was coming from the left ear, it wouldn't have changed with masking noise presented to the right. We'll add an additional 10 dB to the masking ear. If the previous bone conduction threshold was accurate in the left ear, the addition of this 10 dB shouldn't shift the threshold. Masking noise only affects the ear that hears the noise. But we see that it shifted another 10 dB. Shifting or increasing threshold with increases in masking represent an undermasking situation in this case. We're not masking the non-test ear enough to prevent the non-test ear from hearing the test signal. When we increase masking to the non-test ear and the threshold shifts, we just prove that it was the non-test ear that was hearing the test tones. We'll add another 10 dB of masking noise and the threshold shifts yet again. The previous threshold at 35 dB was not the accurate one from the left ear. We'll add 10 dB more. This time the threshold did not shift. It remained stable at 45 dB. This means that the non-test ear, the one that was being masked and having an increasing level of masking delivered to it, was not the one hearing this test tone at this level. If it was, it would have shifted as the masking noise increased. In this case, the test ear must be the one hearing our test tone. We'll add 10 dB more, and still no shift. At this point, we've confirmed that it was the left test ear hearing this bone conduction signal. We have a properly masked bone conduction threshold here at 45 dB. Let's just crank the masking up to 80 dB just to see what happens. And a threshold retest with the masking noise up to 80 dB still did not produce any shift in threshold. This blue region is the plateau, where the hearing threshold remains stable in the presence of increasing levels of noise. This is where an appropriate level of masking is being delivered. We know the test ear is the ear hearing the test tones here. Once we identify the situation, we can document a masked threshold present on the audiogram. What happens if we go higher than that? Let's add 10 dB more of masking noise. The threshold starts shifting again. We'll increase the masking by yet another 10 dB, and the threshold shifts again. This is the third possibility when masking. We can deliver too much noise to the non-test ear when it can cross to the test ear side and contaminate our attempts at testing. We're trying to mask the non-test ear, but it can end up masking the test ear. This is called overmasking, and it does not represent an accurate threshold measurement situation. The masking noise is so loud it's crossing to the test ear side and causing shifts to the thresholds of the test ear. This paper from Liden et al. In 1959 introduced the controlled test method of increasing masking levels to ensure that we'd know when the test ear was or was not the ear hearing our test signals. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.